Hi, let's do some calculus. We're on daily lessons 216 to 218, and we're moving on from area now to volume. What? These are volumes of solids of revolution. So what this is we take an area, so let's say the area of this region, between A and B, and then if we take it and we rotate it, so we go around and around, and imagine anywhere you rotate it, it's like a screensaver from the 90s, which you probably don't remember because you were born way after that. But if you rotate it, what this is going to happen is this is going to leave in its like trail anywhere you go a solid. So you would rotate around this axis, and then what would happen is you would make a shape that looks kind of like that if you had a function that looked kind of like this to start with. So you take the area, but that area is going to be turning into volume as you revolve it around the x-axis or around some axis. And so if we imagine slicing this into an individual one, so if we slice from here to here, think about what shape that would be. Well, any slice over here, there's going to be big circles, over here smaller circles, but anywhere you slice this, you're just going to get a circle. And this is all around some axis, you can see around, this is the x-axis right here. So all of these, there's going to be lots and lots and lots of circles. So imagine if this is rotated towards you, there's a bunch of circles, and right here I've got the x-axis in the middle. If I want to find the area of one of these circles, the area of a circle is pi times the radius squared. This is the area of one circle. But let's think about what this area is. Let's in a little bit more in terms of this function. And remember, this function is, let's call this one, this is the function f of x. So this function from here to here is f of x. Well, if I want to think about what the radius is, the radius would just be the distance from here to here, or if you're thinking about it, the distance from here to here. Or we could say from here to here. And it could be anywhere in this function to here. It's only halfway, because remember, this is going to be rotated the entire way around and revolved until we get a solid. So our radius is only the distance from the x-axis to here. Or we can say area is pi. The radius would be f of x minus my axis of rotation, which in this case is 0, squared. Pi times the radius squared. If I wanted to find the volume, what I do is I have to take all of those areas. There's an infinite number of areas because there's a whole infinite number of circles here, and I add them all together. And so if I add them all, see how here I'm going to integrate this is pi, or in this case we just said that this was the radius squared. So pi radius squared, which means if I integrate this, you can take the pi out in front, but if you integrate pi r squared, or you integrate area, you get back to volume. So think about even just an area being meter squared. So really basic, just an area of a figure is meter squared. If you integrate that, you're going up an exponent to meters cubed. You're going to volume. Okay, so this one was on the x-axis, so where y equals 0, but we could actually do this around any axis of rotation as long as there wasn't a hole in the center. You're like, well, what happens if there is a hole? So you see this one, if I rotate, and this is my solid region, but I'm still rotating it around this axis. I'm going to have a very similar figure to before. It's going to look a whole lot like this one. A whole lot, that's funny. But it will have a cylinder through the middle of it because this will also be rotating. So if you're looking to this to the side, there would be a place where you like stick your arm through it like a superhero. That's what I feel like superheroes would do if they saw something like this. Or they would just make the hole in the first place in the first one. So here we have a hole in the center. But let's think about this. If I have a circle that has a hole in the center, we can actually find the area of that too. We can say the area is the pi, the radius squared, minus pi r squared. It's just in the first one, we have to do the bigger radius minus the smaller radius. So from here to here would be the big radius, or r1. Here to here would be r2. So you take the outer circle minus the inner circle. I can still do that here. And you know how we just said that the radius was the outer, this one says outer function, but you see the distance from f of x to the axis, so in this case to 0. Oops, sorry. If I want to take here, the radius is going to be the inner function, so from here to here, from here to here, the inner function minus the axis squared. Okay, this is all super theoretical right now, but if I did this, see how I've got this pi and pi? Couldn't I do this? Pi times, I could do that. That's what's happening here. This is my first radius, my bigger radius, the smaller radius. Okay, so let's actually do this. So when this one says the outer function, it's to be defined as the function that's further from the axis of rotation, which means right here, if my axis of rotation is here, I need my bigger circle minus my smaller circle. The inner function is the one that's closer. So in this case, my inner function is just this line like y equals, what is this? Y equals c, but it could be y equals 1, 2, whatever. So we've got an outer function and inner function. Whew, that's a lot of me talking. Let's do this and practice it. Well, I might actually keep this around so we can use it. Some of you are going to be excellent at visualizing these in your head right away. Some of you, it's going to be like, I'm going to need some work on this. That's okay. So if the axis of rotation of the x-axis is parallel to the x-axis, so in this one, it's just saying sometimes the axis of rotation will be at y equals 0, sometimes at y equals some other value. The integrand needs to be in terms of x, and this needs to be on all in x values. So in the first one, we're just doing a regular integral all in terms of x. Consider this region, and I've got y equals x squared, and I've got y equals x plus 2. Okay, so I'm starting this with this region, and I can see here it's shaded, and it's saying I rotate around the x-axis. Let's think about what the x-axis is. It's this line right here. But if I were to write the x-axis, it would just be line y equals 0. So if I want the volume of this region, I'm going to say, and I've got the x-axis right here. When this is rotated around this axis, do you see how sometimes there's going to be a hole on the inside? Like if this were rotated, it would be the outside is going to be almost like a pyramid on its side. And then the inside is going to be like one of those things at a grocery store that you can like put a penny down and it's like swirling around on the inside. It's kind of smooth on the inside. That's what's happening here. And if you can't really see it, it's okay. You can just go with the pattern then. You can say, well, I know to find volume, here's if there's not any holes at all, but this one has some spaces. I'm going to do from A to B, well, pi. And I'm really doing pi r squared minus pi r squared. Pi, the radius squared, minus pi, radius squared. But how I would do that is like this. I'm thinking, okay, what x value is this shaded region starting and where is it ending? X equals -1, and it's going the whole way to 2. And then I'm thinking, what goes in here? So if I'm rotating around like this, rotating and rotating and rotating, my axis is right here. If I go up and hit my function, like straight lines of my function, vertical line, this will be my inner function. I hit it first. Keep going. The one that's furthest away is my outer function. In this case, this is the line y equals x plus 2. So my outer function is x plus 2. Remember we said minus the axis of rotation, which is y equals 0. You don't have to put the y's in here. It's just x plus 2 minus 0. So this is my bigger radius minus my smaller radius, which would be my inner function, in this case x squared, minus my axis of rotation, which in this case is y equals 0. And now, this is old news. We can just solve this. So I know this is pi from -1 to 2. I'm going to simplify this a little bit. This would become negative x to the 4th. This is going to be x plus 2, the quantity squared. See how much I want to do this. This would be x squared plus x plus 2 times x plus 3 would be x squared plus 2x plus 2x, which would be 4x plus 4 minus x to the fourth. And if you wanted, you can find the antiderivative and then do f of b minus f of a. But I just want to make sure that you're okay with setup right now. So if you just want to solve this and you're like, no, I don't want to do the antiderivative, I want to just figure out what this answer is, don't multiply by pi yet. I'm just going to do math 9. And I could have even done it up here just to make sure I don't make any mistakes. So negative 1 to 2. X plus 2 minus 0 would still be x plus 2, the quantity squared, minus x squared squared. We got 14.4, but don't forget we have to multiply by pi. Or if you push, or if you did it the other way and you did a bunch of work and you said that this was 72 over 5 pi, that's okay too. Same thing. Okay, so outer axis, or I'm sorry, outer function minus the axis squared, because it was the thing furthest away from y equals 0. The function that was closest, in some cases it's even just touching, is the x squared minus 0, or x squared minus the axis squared. So outer function was x plus 2, inner function was x squared. I can speak. Okay, how about the next one? And then I'm going to have you do that last one on your own. But for right now, we've got this line and it says find the volume where you're at y equals 4. So I know y equals 4. It's going to be way up here. So this is going to look way different. If I rotate this, it's going to be going this way. Remember this solid region. Don't worry about these other lines. It's just this solid region. It's going to be making a new shape. This is going to be like a curved outside. If you think about kind of a crazy looking bowl, and the inside would be more of a pyramid shape. The outside is more like curved around the outside. If you can't see it, again, that's okay. Just go with the formula then. I'm going to take pi, sum radius squared minus sum radius squared dx. Whenever you're doing this, you have to think about what's my initial x value, what's the last x value, like of the shaded region. So I'm going negative 1 to 2 again. And here's where you have to think about, okay, I want the outer function. So if this is y equals 4, and I draw a vertical line, I can't go up, so I have to go down. The first function I hit is this x plus 2. That's the inner function. So that's the x plus 2. Minus my axis, and this one is minus 4. Over here, my outer function, so if I went from my axis of, I'm sorry, this was rotated about y equals 4. So if I start here at y equals 4, and I go down, I already hit x plus 2. The one that's further away, the function that's further away, is this x squared. But remember, I'm finding the radius, so I need to say x squared minus 4. You could do this by hand. You could actually simplify all this out, find the antiderivative, and if you're like, I want to do that, I need that practice, do that now. Pause this, do that now. But if you're like, nah, I'm cool to just put this in my calculator, don't just watch me do it, you should do it too. So math 9, from negative 1 to 2, x squared minus 4 minus x plus 2 minus 4. Don't forget about squaring it. All of this is in parentheses, that's all good. So I forgot to put the x again. Sorry, I couldn't see it. I got 21.6. Don't forget about the pi. If you wanted to put pi in front right away so you didn't forget it at the end, you could. If you wanted to rewrite this and you said, I want to write it as 108 over 5 pi, you can do that too. Okay, I know this is going to be tough, but try this one. See what you can do. Remember, y equals negative 2 is the axis of rotation. This is what I'm revolving around. So y equals negative 2. Think about, how would you write this integral? if we're talking about the outer function minus the axis squared, inner function minus the axis squared, my axis is at y equals -2. If I start at -2, y equals -2, and I just use a vertical line up until the first function I hit is this x squared. That's my inner function. Keep going. There's my outer function at x plus 2. Minus my axis of rotation, so this would be minus, in this case, -2, or you could say plus and +2. Over here, just if I wanted to be sure, y equals -2, the first thing I hit is that x squared, again, minus -2, or you could say +2. Gonna multiply, so here, remember this is pi radius squared, that's why we have both of these squared. If I do math 9, this would be the same as x plus 4 quantity squared minus x squared plus 2 quantity squared. Pi times 32.4, or you could say 162 over 5 pi. Doesn't matter. Either one of those is fine. Okay. This is all when you're rotating about an axis. Let's do more. What if instead of going this way or this way, I went this way? Boom, boom, boom. If you go to the next page, this one talks about the axis of rotation is all parallel to the y-axis. So instead of rotating this way or this way, I'm going to rotate this way, which actually means these things, instead of saying y equals plus or minus the square root of x, I'm going to solve these both so that I get x by itself. I want everything in terms of x. So if we're talking about the y-axis, and this is at x equals 0 is the y-axis, think about it up and down, x equals 0. We want everything to be x equals. So here, if I square both sides, I would get x is equal, or I'm sorry, I messed that up. Y squared is equal to x. Over here, I'd have y plus 2 is equal to x. So this one is going to be y squared. This is going to be y plus 2. Okay, let's keep going. So then I'm thinking, what do I do? If I'm finding the volume, I'm still going to do volume is equal to pi, the outer function minus the axis squared, minus the inner function minus the axis squared. What changes in these problems is everything is with respect to y, so dy. So anything in here should be y's instead of x's, which means if I'm going from this point to this point, these are my intersection, I'm going to go from my y value to my y value, which in this case is -1 to 2. My outer function, so if this is my line, I can see this is even touching this function at x squared. But if I go up, the one that's further away is this y plus 2 minus the axis squared. I can see it's even touching down here, so it's definitely going to be y squared minus 0. And then when you solve this, you actually do it the same way as before. You don't even change the variables in here. You're still using x because x is the only variable that we're using in this problem. So I'm still going math 9, -1 to 2. Remember, you multiply your answer by pi. When you're done, if you want to just put it here at the end, you can. This would be the quantity y plus 2, but I'm just going to write it as x plus 2 in my calculator. Seems kind of crazy, but that's okay. This is x plus 2 minus 0, so y plus 2 minus 0 is the same as y plus 2 squared. Minus y squared minus 0. Again, you don't have to. Whole thing squared because this is pi r squared, radius squared again. And then at the end, this is just a variable, so I'm putting in dx. Hey! And you might think, isn't this kind of the same thing we got over here? Or you could say 72 over 5 pi. Isn't that the same thing? Oh yeah, it is. Because you see how this shape, if I just turn it on its side, it's the same thing. That looks weird. Don't turn it that way. Nope, nope. Something looks weird about this. Oh, it's just going another direction, but you can see it's kind of a mirror image because it's flipped. Everything's over y equals x. But anyway, this is the same shape. I could put this, these two shapes are exactly the same region. I should say that. They don't look exactly the same on the side because things are flipped around still. But we get the same answer. And you're like, are these the same? Nope. X equals 4, x equals 7. So one of them might be the same, but one of them is not. So in this one, if I've got this line x equals 4, and I've got this line x equals 7, I want you to recognize that x equals 4 would be right here, x equals 7 would be over here. Set up both of these integrals. Ready? Go. You try it. I'm going to pause it. You try. Okay, when you set this up, did you set it up as pi? So even just really basically, this is going from my y value of -1, from my y value of 2. Then I'm going to do outer minus the axis squared. So remember, x equals 4 is right here. My outer function is going to be the function that's furthest away. And instead of making a vertical line right now, I'm going to make a horizontal line. So horizontal line, it touches this one first, the y plus 2. I'm going to go the whole way to y squared. So I have y squared minus 4. Because this is my axis of rotation. So I did my outer minus my axis of rotation. That means y plus 2 is my inner one, minus 4. The only thing that changes here, actually it doesn't change the axis because I've got x equals 7 over here. So this is still going to have the same outer, is still going to have the same inner. The only thing that changes in this one would be, this would be y squared minus 7. And this would be y plus 2 minus 7. Okay, so look, compare yours with mine, see, did you get the same thing? And you can do a whole lot of work in these ones where you are simplifying, finding the antiderivative, or you could just use a calculator. Hey, that's what I did here. See, look, I did a lot of work, but you end up using a calculator anyway. And this one, you should get 21.6 pi. Which that's the same thing we got in the other page when it was revolved around the line y equals 4 and everything was just backwards. Or you could say 108 over 5 pi. And this one, this is actually a little bit different. This one was 48.6 pi, or 152.681 if you multiply by pi. Or I can say 48.6, and if I make that a fraction, I get 243 over 5 pi. But this is good for me. Okay, this is tricky. We're going to practice. That'll be great. Let me know what questions you have and how I can help you. Thank you for learning. Thank you for listening. Thank you for working. I appreciate you. Bye.